Hello everyone, myself Hitanshi Acharya and this is task 3 Iris flower classification under the internship program at Courseoft. The aim is to develop a model that can classify the iris flowers into different species based on their sepal and petal measurements. First of all, let's import some of the important libraries. In this case, I have imported NumPy, Pandas, Scikit-learn, Matplotlib and Seaborn. Now let's download the dataset. For downloading the dataset, I have used the inbuilt SNS dataset, which is termed as Irish, which is the same dataset that has been given into the task list. So yeah. Now on the next step, what I did is I have factorized the species column. As we have known or observed that there are three species that we have to classify into. Those species are Setosa, virginica, and the third species is Setosa and versicolor, right? So, after factorizing, it gives the corresponding numeric values. So, after using this factorize function, the corresponding values 0, 1, 2 has been given to the particular species. And I have used this describe function in order to see the statistical information regarding the um, particular data set. Also, I have checked that whether there is a null values or not, and very fortunately there is no null value present into the data set. Now it's time to visualize our data set. So I have visualized this time with the help of the 3D plot, and I have visualized with the help of the petal length, petal width, and giving hue as the species. As we can see, when we have given the petal length and petal width, the particular three species has been divided automatically into the three different parts, and we can see here the three cluster formed after the visualizing with the help of the petal length and width, where into the sepal length and sepal width the scenario is quite opposite. So there's no such classification we can predict on the basis of this 3D scatter plot. But let's not limit ourselves into this. Let's visualize with the help of the 2D scatter plot. Here itself also we have seen that using the petal length and petal width, the data set is quite able to predict or classify the data set into the three classes or label itself, which is Setosa, versicolor, and virginica, while into the sepal it is not quite doing well. So we are definitely will go with the two parameters only, which is petal length and petal width. So for classification, first of all we have to clusterize it, and before clusterizing we have to predict that which number of cluster we are going to lead with. So for that I have using the elbow technique. So from the elbow technique, this particular is piece of code is able to given the output of the SSA, which is sum squared mean error, and this graph, which is SSE versus K range, we have seen the elbow is on the third number. That means the efficient or optimized number of cluster is here 3. So we'll move forward with number of cluster is equal to 3. And I have put the random state as 0 because I don't want it take the new values at each and every iterations, that's why. And after this, what I have given as the output is this particular 0 to 1 based arrays, and this is nothing but the species itself. It has been able to clusterize the whole data set into these. So what I did is I have inserted this y predicted into the our data set with the name cluster. So our data set after this will look like these species and the cluster adding into it. Okay, now this is the something, but let's see that what I did here is able to see able to accuracy measures how much it scaled into it. So for accuracy measure, what I did is I had drawn the confusion matrix with the already clusterized one, which is species, and after prediction, which is mentioned into the cluster. So what I did, I have construct or draw the confusion matrix with the species and cluster column itself, and this is what it looked like. But for better visualization purpose for the user, I have just given some of the colors and all, and for that we have here clearly see that the our particular predicted classes has successfully achieve some of the accuracy and the measurements and the classification of our data set very much into the nice manner. Thank you so much.